This is a video on hyperbolas and tangent lines. The question states, find the equation of the tangent line to the hyperbola through the point s comma t. And the equation's given as x squared over a squared minus y squared over b squared is equal to 1. So to find the equation of a tangent line, I need to have a point, and that's s comma t, I've got that. And I need to have a slope. The slope of the tangent line is the derivative at the point. So I need to find the derivative, or dy dx, for this curve. I differentiate implicitly to do this. That means I take d over dx of both sides. The derivative of x squared is 2x, so I get 2x over a squared. The derivative of y squared with respect to x, we get 2y, but then since the variables don't match, we need to multiply by y prime. And then we have over b squared. And the derivative with respect to x of 1 is just 0. So let's solve for y prime. I'm going to subtract 2x over a squared from both sides, and then multiply by negative b squared over 2y. And I arrived at y prime is equal to xb squared over ya squared. Now I want the slope of the tangent line at the point s comma t, so that means I plug in s for x and t for y. And I get my slope is sb squared over ta squared. So now we can plug it into the point slope formula for the equation of a line. Our point is st, and here's our slope. So we get y minus y1 is t, equals m, or sb squared over ta squared, times x minus x1, and x1 is just s. So that's the equation, but I'm going to make it look a lot prettier by doing a bunch of magical algebra. And the first step in the magical algebra I do is to multiply both sides of this equation by t over b squared. And when I do that, I get t over b squared times y minus t. The t times 1 over t, they cancel, and the b squareds cancel, and I'm left with s over a squared times x minus s. So now let's just multiply through, and I get ty over b squared minus t squared over b squared equals sx over a squared minus s squared over a squared. Then I'm going to bring my variables over to the right-hand side and my constants over to the left. Remember, my variables are x and y. All the rest are just constants. So I do that, and I get s squared over a squared minus t squared over b squared equals sx over a squared minus ty over b squared. Now look at the left-hand side, s squared over a squared minus t squared over b squared. Since the point st is on this hyperbola, that means if I plug in s and t for x and y, I'm supposed to get 1. Well, s squared over a squared minus t squared over b squared, that is plugging in s and t for x and y. So the left-hand side just becomes 1. And then I can write down my final answer. I'm going to switch the 1 over to the right and the rest over to the left. And what I get is sx over a squared minus ty over b squared is equal to 1. And I'm done with the problem.